Hello everyone, and welcome back to WOA's Introduction to Programming series. My name is Amanda Camarada, and I am studying Mechanical Engineering at the Colorado School of Mines. I'm part of the Technical Development Committee here at WOA. In Episode 2 of the Introduction to Programming series, we will learn all about variables and data types. So let's get started. A data type is a classification of the elements in a programming language that tells the computer how we plan to use that data. For example, if we wanted to save a number, we would have to classify that number for our computer so that it can know whether the number is an integer or a rational number, how large the number needs to be, and so on. The data types we will talk about today are common across most programming languages. First, let's talk about how computers read data and how we can take advantage of that to understand programming. In programming, we are essentially giving instructions to a computer to perform a certain action or sequential actions, like adding two numbers. To add these numbers, they first have to be stored in the computer. In a computer, all data is stored in millions of tiny bits. These bits, which is a short form of binary digits, are basic units of information that represent a state with one of two possible values, 1 or 0. A group of 8 bits is called a byte, and we commonly use bytes to signify the file size of objects in a computer, such as an image being 40 megabytes, or a video being 2 gigabytes. Even a simple data type takes a certain amount of bytes of memory for a computer to store. The first data type we will cover is an integer. These are simply numbers that don't have decimals. They come in the form of shorts, ints, and longs. Shorts can hold 2 bytes, so numbers between -2 to the power of 15 and +2 to the power of 15. Ints can hold 4 bytes, which are numbers between -2 to the power of 31 and +2 to the power of 31. And longs can hold 8 bytes, which are numbers between -2 to the power of 63 and +2 to the power of 63, which is a really large number. Another numerical data type is the floating point data type, or a float. Floats have decimal points, so they can represent rational numbers such as fractions and scientific notation, which you might remember learning about in science class. It's a notation used to represent numbers at very large or small magnitudes and to simplify calculations. For example, we need to use scientific notation for values like the distance between the Earth and the Sun, which is over 149 billion meters. In Matlab and Python, floats are single precision numbers with 4 bytes of memory, while doubles are double precision numbers with 8 bytes of memory. Here, precision relates to how precise your numbers can get. With more memory, you can save a number with more digits after a decimal point, which makes it more precise. Our next data type are characters, or chars, which come in the form of letters, numerical digits, common punctuation marks, and white space. Unlike the high-level languages humans use, like English, the only language computers can understand are binary numbers, or ones and zeros. So how are these chars, or characters, defined in our computers? Well, there's this thing called the ASCII table that assigns a specific series of bits to a letter or a symbol. For example, an exclamation mark is saved in your computer as the binary number 100001, which is equal to the number 33. And if you're confused about how 100001 equals 33, don't worry, we'll post a video about binary math in the future. So you can actually convert a number to a char with the char function in Matlab and the similar char function in Python. So if you were to type char 33 in Matlab, an exclamation mark would be the output. This also works in Python, as you can see here. If you wanted to get the number associated to a char, you can use the double function in Matlab to find it by typing double exclamation mark. And in Python, you can use the ORD function to convert a char into an int. Now let's move on to strings, which are chains or combinations of characters. These are referred to as a string data type and can be used to form words or phrases. This can be very useful in searching for words or phrases in a particular document, like when you use Control F on a web page. To make a string, you can combine a bunch of chars. For example, T, E, and A are all individual chars, but you can combine them to form the phrase T, which is a string. You can also combine two strings in Matlab with the strcat function. This stands for string concatenation, which means string combination, and it looks like this. Strcat, I like to drink, comma T, or with the plus sign. I like to drink plus T. You can also use the plus sign in Python to combine strings, such as typing I like to drink plus T. Another thing you can do is convert string data types into integers, and vice versa, by simply using the stir to num or num to stir functions in Matlab. In Python, simply use the int function to convert a string to an integer type, or the stir function to convert an integer to a string. We'll talk later about specific situations in which we need to convert one data type to another, and this is where these functions are very useful. The final data type we're going to talk about today are Booleans, which have one of two possible values, true or false. True is traditionally expressed as 1, and false is expressed as 0 in Matlab, but in Python, true and false show up as the actual words. Let's go over an example in which Booleans are used. Matlab has a function called isEqual, which compares two values and returns a true, or 1, if the values are equal, and false, or 0, if the values are not equal. So if we enter isEqual 1, 0, the program returns false because 1 does not equal 0. So what would isEqual 0, 0 return? That's right, a true, or 1. That's because 0 equals 0. In Python, we use equal to see if two data types are equal, and that double equal sign also works in Matlab. Typing 1 double equal 1 in Python outputs true. Booleans are also very important for logical statements in programming, which we'll talk about in a future video. All of these data types that we've talked about so far can be stored in variables, which are words used to reference an instance of a single data type. This is similar to how variables are used in algebra, where x can be used to reference a number. To make an integer variable, you simply equate a variable to a number. For example, if you have 5 apples, you can create a variable called apples that you set equal to 5. Then, if you have 10 oranges, you can create a variable called oranges and set it equal to 10. Both apples and oranges are integer data types, but each variable references a single number or instance of an integer. So now you can calculate how many fruits you have in total by adding apples and oranges together, and you get 15. In Matlab, a valid variable name starts with a letter, followed by letters, digits, or underscores. So apples, num_apples, and apples_10 are all valid variable names. But 5 apples, _99a, and !apples are not valid variable names. Variables are also case sensitive, so lowercase a apples and uppercase A apples would be two different variables. The only difference in Python variable names from Matlab's is that in Python, variables can start with an underscore, so _123 is actually a valid variable name in Python, but not in Matlab. Note that when you create variables in Matlab, they can be seen in the workspace. In Python, there isn't a workspace unless you use an IDE, or an integrated design environment, which Matlab has by default. But you can always find out a variable's data type by using the type function. So if I created the string apple in Python and assigned it to the variable fruit, calling the function type with fruit as an input outputs stir, or string. There's a similar function in Matlab called class. So just like the previous example, I could create a variable, fruit equals apples and type class with the input fruit, and it will display string in the command window. To make a char variable, you can use single quotation marks. My char equals A. To make a string variable, you can use single or double quotation marks in Matlab and Python, but in other more complex languages, you generally have to use double quotation marks, such as fruit equals apple. Remember earlier when we talked about the functions num to stir and stir to num? Well, if we created a variable called mynum equals 42 and wanted to convert it to a string, we could use the num to stir function by typing mystring equals num to stir with the input mynum. Now if you type mystring in the command window, you'll see that the 42 is in quotation marks, indicating that the data type value is now a string. You can also check your workspace and see the data type of the variable has changed. You can also print or display the values of your variables in the command window using specific functions. In Matlab, you can print your variables two different ways. The disp function simply displays the value of the inputted variables. Let's again create a variable called fruit and assign it the string apple. So if I want to display the value of my fruit variable, I can call the disp function with the input fruit, and it displays apple. The second way to print in Matlab is by using the sprintf function, which allows you to format a string with placeholders for the variables of certain data types. So for example, if I wanted to print the phrase, I have 5 fruit in my basket, where the fruit part could be replaced by any value, I would first set my variable fruit to apples, then type sprintf, I have 5%s in my basket, comma fruit. And the phrase, I have 5 apples in my basket, is printed. I could also change the placeholder to be the number in that string instead of the type of fruit. I can do this by creating the variable number fruit and setting it equal to 5. Then I can type sprintf, I have %d apples in my basket, comma, number fruit. You could also have multiple placeholders as inputs, such as sprintf, I have %d, %s in my basket, comma number fruit, comma fruit. As a note, you don't actually have to put variables in the right inputs. You could just type in 5 and the string apples, and it would still work. Such as sprintf, I have %d, %s in my basket, comma 5, comma apples. But when you have a lot of data, it helps to use variables, as you'll learn when we talk about loops in a future video. So what do the %s and %d mean? Well, the s stands for string, and the d stands for double data type, which we talked about earlier. Similarly, you could also put %f for float, %c for a char, and as you see here, there are a lot of data types that you could format into your string with the sprintf function. In Python, you can just use the print function to display the value of your variable. So if I wanted to print the variable fruit equals apples, I would just type print with the variable fruit, and the string apples is displayed on the command window. If you want to format a string in Python like you would using sprintf in Matlab, you could use curly brackets as placeholders in a string, and use the dot format function like this. I have curly braces apples in my basket, dot format 5. In Python, you don't need to specify the data type like you do in Matlab. Python just needs you to place curly braces in the place of the right inputs. A cool thing that you can do with Python string formatting is put an order in which you want the inputs to go in. So if I input the string apples first, and then the number 5, and just put curly braces like this, I have curly braces in my basket, dot format, apples, comma 5, that would output, I have apples 5 in my basket. But if you put in numbers to order the inputs, remembering that Python starts numbers from 0, unlike Matlab which starts from 1, you can specify the order of the inputs, like this. I have curly braces 1 and curly braces 0 in my basket, dot format apples, comma 5. That would output, I have 5 apples in my basket. Alright, so that's all we have for data types and variables. Thank you so much for watching, and join us next time to learn more about vectors or arrays and cell arrays.